Welcome to the Learning Pines YouTube. We hope this video helps.
You begin by validating hardware and version alignment. This avoids painful mismatches. Identify your GPU model and its compute capability, then choose the Cuda and cuDNN versions Tensorflow supports. Once chosen, install the NVIDIA driver first, then Cuda Toolkit, and finally cuDNN. Make sure to add Cuda bin and lib paths to path and LD library path on Linux, or update system environment variables on Windows. These environment variables tell TensorFlow where to find Cuda libraries. Once paths are set, create an isolated Python environment. Use virtualenv or conda so dependencies don't conflict. Activate the env, then pip install the TensorFlow build that matches your Cuda and cuDNN versions. This ensures binary compatibility. Next, run NVIDIA SMI to confirm the driver is active and start Python to import TensorFlow. Use tf. Config. List physical devices, GPU to confirm visibility. If TensorFlow lists GPUs, you're executing correctly. If not, revisit version alignment and environment variables. Finish by running a small training loop or benchmark to ensure Cuda acceleration is active and stable. Watch utilization and memory allocation. If errors occur, make sure Cuda, cuDNN, and TensorFlow versions align precisely, then recheck path and LD library path or Windows environment variables. When stuck, capture error logs, output of NVIDIA SMI, and pip freeze. These details speed troubleshooting with forums or colleagues. One key tip: mismatched minor versions cause most failures, so double-check exact version numbers before changing components.
Thanks for watching. Consider subscribing if we helped you.